It's just the knowledge of the coils and how they interact with each other.
I've got the papers that show how many milliamps of current he wanted circulating through the coils. On most of the machines that he built, there were two magnets, north south, two coils of wire between them. Axis of the coils were this way. Now these coils were bifilar wound, which meant the current was passing in one direction through it, then it would go through the other one, and then it would come back through the two. Why you could even generate a voltage out of a coil wound that way, I have no clue. But that's the way he wound them. Now his drive circuitry was outboard in most cases, and this was normal polarity. Let's say you got the two magnets here, coils in between. Now you got the drive coils on the front here and in the back. And these are wound and configured push-pull, so they're wound so that the field would flow this way and then that way and this way and that way through these coils that are sitting right in the middle.
Hey everyone, I'm just going to do a quick video just to show everyone that the coils do oppose. So the partnered output coils do oppose. Now with any setup, your partnered output coils must oppose, and this is something that you must check. You must make sure that your partnered output coils oppose. Otherwise, you're wasting your time, if you know what I mean. Now what I'm going to use is I'm going to use a little magnet. One side's got a bit of black tape on it, the other side hasn't. So one side's a north, one side's a south. Okay, and it's through the long face. So you're up and down through the vertically through the magnet at the moment. One side's north, one side's south. Okay, so what I'm going to do is I'm going to just apply a voltage across each coil. So I'm going to put a positive in because obviously our diodes here will set the polarity, and then just apply the negative to each side, and I'll show you that the polarity of the magnet flips every time we change the polarity, and that verifies. It's a good test to verify that the coils themselves do oppose each other and that you've got your diodes in the correct direction, which obviously, as I said before, it is important. It's important to make sure that your partnered output coils, these coils here, the big coils, oppose each other exactly the same as what Floyd Sweet said, which again, if you go through, you read my website, you'll be able to see the right hand grip rule applied to the VTA, and the obviously each coil has a B cross V, and one is negative, one is positive. Obviously flipping the negative terminals will then give you a positive BXV or B cross V, and once you have two positive B cross V's and you're drawing the same current, the same voltage from each coil, the magnetic fields oppose in the middle, but the current itself, which they deem as the E field, which is the current, the electric field, will double. It'll double from E onto to E, as Floyd Sweet said. So what we'll do is we'll set the camera up, and we'll set it up so that I'll show you the magnet trying to flip as I change the polarity, and we'll do the best we can. Again, everything's a mess, so you're going to have to ignore the mess around me. Okay, so hopefully you can see this all right. Again, I'm just applying a small voltage across each coil individually, and what you'll see is the polarity of the magnetic field change, which will be indicated by the magnet flipping. So what we'll do is we'll apply to the top first. Okay, so you can see it wants to flip to that side. I'll try and do it again so that okay, so applied. Okay, it doesn't want to flip. And again, we'll apply to the bottom, and you'll see it flips there. Okay, so flip again, flip again, flip again, and flip again. So you can see clearly there that the partnered output coils do oppose each other, and again, that's really important. And seeing in the last experiment that the voltages were exactly the same on both partnered output coils, showing the traces, shows that the voltage generated in the partnered output coils is directly proportional to the time rate of change of the magnetic fields between each coil in the partnered output coil. So in other words, what we're saying is statically we've got an electromagnetic induction happening between the partnered output coils, which again the input is only just it's just exciting the coils. What it's doing is it's bringing the coils into a state where the changing magnetic fields within the two coils is identical, and what it's doing essentially is generating the voltage, and then obviously at the point of turn off on your input, what's happening there is because the partnered output coils still have a voltage on the terminals and there's a load, then the partnered output coils will pump current, and the current is pumped until the voltage drops pretty much to zero. So in other words, as long as there's a voltage on your partnered output coils, the partnered output coils will pump current. Okay, and again you can see that the polarity is different. Okay, so each coil holds a different polarity. As soon as a voltage is generated, then the current will be pumped because each coil opposes each other. Okay, pretty much we're following exactly to a T what Floyd said in his paper. All we're doing is really reading between the lines. And again, no one else has decided to follow this up. This is something that we have we've done on our own. We've decided to learn. We've decided to study. We've decided to make advancements in a field that no one else has decided to take on. Okay, and again, we've seen machines in the past. We've had machines running on the web page. Again, everyone just dismisses it as boohoo, you know, because they can't do it. They think it's nonsense. Well, the nonsense really is on them. You know, what we're seeing is an effect here that can't be denied, because anyone can reproduce this. And all you need to do is just improve on this. All you need to do is just make this work better. Now, again, I want to emphasize the point that I made before on the forum. The magnets are not important. Don't make something magic when it's not magic, because it's just not how it is. We need to think logically. We need to think in terms of voltage and a current. We need to understand how voltage and current is generated and the current's pumped. And partnered output coils do that. Now again, the difference between this device and the device I've shown previously is there is a small gap. Okay, we've got two sets of eye laminations here, one set on the other side, and there is a small gap in the middle. The gap in the middle does emphasize or does exaggerate this effect, and it does change the way the device works a little bit. It gives the gap itself in between the two coils gives the partnered output coils a chance to well, it's a little bit hard to explain, but basically each partnered output coil, because of the gap, can function independently of each other a little bit more freely. Now we could play with the gap size. We could, you know, instead of 3 millimeters, we could set it to maybe 1 millimeter, and it will change the way the device works. I think the distance of the gap is an important aspect, but any gap will do the trick to actually start learning. Again, the magnets are not magic. Don't turn the magic, you know, don't say there's magic when there is no magic there, because it's not the case. We need to We need to think logically. We need to be practical. We need to think in terms of current and voltage on the output, okay? Because really, at the end of the day, what we're doing is the whole entire goal is to power load. Now, Floyd Suite managed to do it in a small apartment 39 years ago, and we still don't know the full truth of the VTA. There were so many lies told. Even now, there's still so many lies told with some of these people online, it's just a joke. Some of these people online honestly need to be put in jail for some of the activities that they've gotten up to in the past. But that's a different story, and a story for another video. In the meantime, that's a way to check and make sure that the polarity of the partner output coils are correct. Is basically just apply a small voltage to each coil individually, and that makes sure that your partner output coils oppose each other, and the opposition of the partner output coils is critical. Hey everyone, it's just going to be a short video today. I want to show an effect that was described a long time ago by the early Floyd Suite papers. Now, I haven't shown this effect before, and no one else seems to have seen it. It's definitely an effect that you will very easily see once you have the right polarity, and we may possibly have seen this effect with some of the early Akula work. It takes a little bit of understanding, a little bit of learning, a little bit of messing around to actually get there and learn it and actually see this effect happening. You have to mess with the polarities. It's pretty obvious once you see it though. Now, what we see is we see an upper and a lower bandwidth limit, which is very low in the frequency range. So anywhere from 20 odd hertz up to about 2 kilohertz. Anything beyond 2 kilohertz, we don't see this effect. It seems to sort of run out and run off. So what we'll do is we'll boot it into life. Now, so you're aware, we have a common common ground here. Okay, so we have 3 coils, the same old 3 coils in there, which I've shown for a long time. We have the input on this side, which is just a small coil. I think it's something like about 100 turns or something like that. Small gauge wire. On this side we have 2 coils output. We have the center tap in the middle here, an output here and an output here. Obviously our diodes here and here. The center tap is a common ground for both the partnered output coils. They're wound and shown and connected like I've shown for a long time. Our load is just a common load, just a globe. Now everything's a mess at the moment. You're going to have to forgive me. I've been super busy. Okay, so the coil structure itself is pretty straightforward. I've shown it for years, and I just want everyone to know this is an effect that you wouldn't have seen before. It's something it's different. It's new. It's pretty amazing. Now, something I want to point out. Floyd Suite used a sine wave oscillator and he used a square wave oscillator on his machines. And early on in the piece, he said that you had to use a sine wave, and the sine wave had to be really clean and all that sort of thing. Well, at the moment, I'm just using my H-bridge just on one channel. So we're using a square wave, and I'll show you what we've actually got happening. Okay, I'm going to switch the machine on. At the moment, we've got 213 hertz we've got a 20% duty cycle, which seems to be fairly important. You've got to adjust your duty cycle to try and get this. Now, if you watch on the scope, you're going to see the amplitudes will start off at a certain rate, and then they quite quickly increase in amplitude. The amplitude increases without me even touching the any of the settings at all. So I'll show you that now. So here we go, and see, you can see the amplitude in there increasing quite a lot. Now, as the amplitude increases, you actually see the load increase as well. So the brightness on the globe will increase a lot. This, as it is at the moment, what I'm showing you is not above unity. This is an effect, and I've said for a long time now, just look for the effects, because the effects are where, if you find something that's not been seen before, which pretty much is this, then this could lead to something much bigger. And in my opinion, this leads to something much bigger. Okay, this is just the start of something amazing. Now, if I switch it off, and again we're going to switch it on, and you can see the amplitude increases drastically. So there's a lot of amplitude gain after the actual switch on. Now, the obviously, like we've sort of talked about now for a long time, the current is pumped from source. The source is the charge in the copper wire. Charge being free electrons, or free charge, if you want to call it that, the elementary charge, which is really the electron, which is pumped down the wire. Now, if you think about it, the resistance of the load, all that sort of thing, well, there's our pumping. That's our pumping. So we'll do it again, and you see increase on the amplitude. Now, as we do this, the input current stays pretty much the same. If anything, it probably goes down a little bit as the amplitude increases. And then we have it. Okay, so I'll show you again. We'll switch the machine on so you can hear it a bit better. I'm going to switch it off, and we'll take over to the load. Sorry again for the mess. Alright, try and get it focused, and we'll switch it on, and you can see as the amplitude increases, the brightness on the globe increases. Now, in my opinion, this is a very important effect. If you want to know how the Floyd Suite VTA works, this is part of it. This is part of the answer. We'll do it again just so I can show you. And again, as the amplitude increases on the machine, the input current does not increase. If anything, it goes down. Now, I just want to reiterate again, the input current, if anything, it goes down, but there is a resonant frequency. We'll sweep now. I'll show you. So we're just sweeping the frequency. Going back up now. And if anything now, as we're getting up in frequency, the light is starting to actually dim a little bit now, and if you look closely, and as we climb up in frequency even more and more and more, the light will eventually dim right out. Eventually. We'll switch it over to a bit faster. We'll go up a scale. There we go, starting to dim now. Now, we're about 2.5 kilohertz there at the moment. Okay, so this is low frequency. Okay, we're dealing with low frequency electromagnetic induction. Okay, the way that the coils are wound and wired produces this effect. This effect has nothing to do with the input. The input is just an excitation. The input current itself does not change while we're doing any switching or anything like that. And you can see we're going right down now and it dims. So probably about the brightest is about, well, probably about there. It's around about the brightest on the globe, and that's 639 hertz. Now you remember that Floyd Sweet's early machines, one of the early machines he said was resonant at about 400 hertz. Well, here we see 639 hertz. So I can't stress this enough. This is a really, really important effect. This is something that needs to be studied further. This is going to open doors for people that currently are not yet understood. We're dealing with something here that there's no link between input to output, okay, which should sort of speak volumes to most people. What we're seeing is an output that is frequency dependent at low frequency. Everything here aligns with what Floyd Sweet had in his early experiments. This is a direct correlation to Floyd Sweet's early experiments.